All right, in this video, I'm going to go over some notes and some practice problems with equilateral and isosceles triangles. We're going to start with isosceles triangles, looking at a little bit of some vocab that you may know, you may not know, so it could be review. So the two congruent sides of an isosceles triangle are called the legs. Okay, the angle where those legs intersect is called the vertex angle. All right, the side that's opposite the vertex angle is called the base. And the angles along the base are called the base angles. Okay, now two theorems, or really just one theorem, and then we're just going to do the converse of it. So the theorem that you need to take away from isosceles triangles is called the base angles theorem. All right, so kind of looking at this figure here, if we have two sides of a triangle are congruent, right? So if you notice, I'll highlight here, we have these symbols. That tells you that those two sides are congruent. So if two sides of a triangle are congruent, then, all right, here's what the base angles theorem states. These angles that are opposite them, so angle 2 and angle 3, are going to be congruent. So then the angles opposite them are congruent. All right, so that's called the base angles theorem, and I'll be using this sentence a lot in doing some practice problems here soon. Now the converse of that, right, if you switch the order, is if two angles of a triangle are congruent, then the sides opposite them are congruent. All right, so again, we've done this for a lot of different theorems, right? Throw that word converse in there, you're just going to change the order. All right, so let's look at equilateral triangles now. So for a triangle to be equilateral, all right, it's only true if the triangle is equiangular, which means that all the angles are the same. So you guys know from equilateral, with the way that we described this a couple weeks ago, is all the sides have to be the same. All right, so now we're saying that's true, and also all the angles will also be the same. So for example, if they're telling you that the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C, then I'm going to write down that segment BC is equal to segment AC, which is equal to segment AB. And you can also go vice versa here. If they tell you AB is the same as BC, which is the same as AC, then angle C has to be equal angle A, which is, oh, that's not an A, sorry about that. Angle A, try again. There we go. Angle A, which is also equal to angle B. All right. So that's what happens when you have an equilateral triangle. Obviously, you know this from your days in middle school. Okay, so let's do some examples kind of using this information. So these first two, we have the first triangle, JKL, and I notice right away, I see those two little tick marks that tell me that those sides are congruent. So using our base angles theorem, if two sides of a triangle are congruent, then the angles opposite them are also congruent. So that means this angle and this angle are going to be the same. So angle J is going to be 68 degrees. All right, now angle K, right, using my understanding that 180 is the total of all three of the angles, all right, and I subtract the sum of those two, that's going to give me to equal angle K. All right, so putting those together, you get 68 plus 68, that's going to be, I believe, 136, all right? And then 136 taking away from 180 degrees is going to be 44 degrees. That's the measure of angle K. All right, let's go to the next one, triangle DCE. And again, I see these two symbols, all right, which tells me that two sides of a triangle are congruent, all right? And I know if that's true, then the angles opposite them, so angle C and angle E, are also going to be congruent. So before I even get my answers, I know that they're going to be the same. All right, so that same understanding of, let's subtract the 106, all right, and 180 minus 106 is going to be 74 degrees. And so that is the sum of both angles C and E. So if I divide that by 2, that will give me the measure of both of these angles. So that's going to be 37 degrees for angle C and for angle E. Okay, let's try number 3, a couple triangles here. All right, again, in number 3, this first triangle, I notice that I have these two symbols that tell me that they're congruent. So using the base angles theorem, if two sides of a triangle are congruent, then the angles opposite them are also going to be congruent. All right, but this time I don't actually have a value, I have expressions. So I'm going to set 4x plus 7 equal to 9x minus 33. All right, when I do that, I'm going to move the 4x to the other side to subtract that to get 5x. Move the minus 33 over with addition to get plus 33, which gives me 40. So x is equal to 8. All right, finally, I have the converse happening. So in this one, I notice that we have these two angles are congruent. So if those two angles of a triangle are congruent, then the sides opposite them are going to be congruent as well. That's that converse of the base angles theorem. So I'm going to set 15x plus 7 equal to 23x minus 17. All right, similar to what I just did, I'm going to move the 15x over with subtraction to get 8x. Move the minus 17 over with addition. 7 plus 17 is going to get 24. So x equals 3. All right, so we finally got a chance to do the converse. All right, let's do one more and then we'll be finished. All right, so number 4 says triangle PQR is equilateral, and we want to solve for x and y. So the moment I see that it's equilateral, I know that all of these are going to be the same and all the angles are going to be the same. And you should know if the sum of your angles has to be 180 degrees and they all have to be the same, right? You probably already know this, but if you divide that by 3, that tells you that all the angles have to be 60 degrees. So the first thing I'm going to do is this is angle R, but if I find that, that could tell me the x value, and I know that angle P and angle Q are going to be the same as angle R. So I'm going to set 7x minus 3, that expression, has to be the same as 60 degrees. Move the 3 over with addition, you get 63, divide by 7, and x is equal to 9. All right, and we know that because equilateral triangles are equiangular. And then finally, it's up to you. You've got options here because you've got 3 different side lengths, PR, PQ, and QR. I'm going to set PR equal to QR. So I'm going to write 11y minus 23 equals 9y plus 1. Subtract the 9y over, it gives me 2y. Add 23 to the other side. 1 plus 23 gives me 24. So y is equal to 12. So that gives me x and y from this equilateral triangle. All right, guys, so that's it for isosceles and equilateral triangles. Don't forget to check the practice problems with the key on Canvas. Try the homework and come see me with any questions. Good luck.